AP Calculus AB, a particle motion exam problem. I'm going to tell you what exam it's from in just a minute. I'll get a little bit farther into the video before I start writing stuff like that. But the situation is we have two runners, A and B, who run on a straight racetrack for t is greater than or equal to 0 and less than or equal to 10 seconds. The graph above, this graph right here, which consists of two line segments, shows the velocity in meters of runner A. So that's runner A. The velocity in meters per second of runner B is this, right? So this is B. So we're asked to find the velocity of the runner at time is 2 seconds, right? So this is the velocity is this. So what I did was I just took the slope of this thing, right? And multiplied it by 2. So I find the slope of this. The slope of this is 10 thirds, right? So I get 10 thirds, because it's 10 thirds x, right? Or 10 thirds t. Well, 10 thirds t, and t is 2, would be 20 thirds. This is crucial because it's a way they always screw us for points. Is it says here, indicate units of measure. Please don't screw that up. Units of measure is really easy. It's just meters per second. Meters per second. Also, if you decide to give them this answer as a decimal, then make sure you use an approximation sign, because it comes out to be like 6.666 or 6.667. Those are not perfect numbers, so you would use your approximation sign, right? The velocity of, so this is the velocity of A. Velocity of B, right, is equal to this. So 24 times 2 over 2 times 2 plus 3, which is equal to, what was it, 48? 48 sevenths, right? So 48 sevenths meters per second. There's that one, and there's this one, right? I'm not giving myself enough room, I apologize, but hopefully you can see this, right? So I'm going to go on to the next part of the problem here. Next part of the problem is find the acceleration of runner A and of runner B at t is equal to, well, the acceleration of runner A, right, at t equals 2, right, is just the slope of this, right, because we want the derivative of this. So this is 10 thirds t, right, 10 thirds t. So velocity at that time is 10 thirds t. So v prime at t, runner A, is just equal to 10 thirds, isn't it? And it would be 10 thirds meters, right? This is acceleration, so it's meters per second squared. Okay? Now on the other one, because this is from a calculator section, it looks like hell. What I would do is this. I would take, so this is for A, right? Equals runner A. Circle this, right? Give them their answer here. Over here, I'm going to give them the answer for runner B. Well, it's equal to V prime, and they're asking for 2, right? So V prime at 2, which is equal to acceleration at 2. And in this case, look, I'm just telling you, I would take this in, put it into my calculator. I would take its derivative. You don't need to show them on a calculator section. You don't need to show them this math, right? Tell them what math you're doing. You're saying, okay, given acceleration of runner A, well, acceleration is the first derivative of velocity, which here's the acceleration, right? You gave them its B here, so I would write that the acceleration is, I plop that into my calculator, and I'd give them that back to them at 1.469 meters per second squared. You know, I might do something. I just kind of screwed myself over for room here, but I would make sure that I wrote B, and then I made sure they know this is runner A, runner B. Other than that, this is good. Remember, on the calculator section, you don't need to show them your chicken scratch. You don't need to show them, like, here, please don't let me find out that you showed them that you use the The quotient rule, they don't give a damn about that. They want to know, do you know what type of calculus? We're in the wrong section to be showing them that much calculus. Just tell them what is the calculus of this problem, all right? Here, we're asked to find the total distance, right? We're asked to find the total distance. Remember, here, that distance is the integral of this thing, right? So for runner A, this is what I'd say. For runner A, total distance. They're going to take this, and they're going to love this answer. Total distance is equal to, and then look, I'm going to go back up here, and this is all of the distance that I have. And this is this, and this out here is the point 10, 10. And they gave us this. I just didn't write it down. I'm sorry. So this is the point 10, 10. So this is 0 to 3. So we have 3 times 10, right? I'm just finding this area right here. It happens to be a right triangle, so times 1/2, right? Plus this area over here, right? Plus the area of this rectangle that's left over here. And it has a base of, well, it's 10 minus 3 is 7, so 7. And it has a height of 10, doesn't it? It has a height of 10. Whoa, 10. So seems to me that this is going to be 30. 1/2 of 30 is 15. 15 plus 70 is 85. So I am going to show them this little bit of math here. I'm going to show them the math that we just showed together. That it's 1/2, 3 times 10 plus 7 times 10, right? Equals 85 meters. Distance A. Then I'm going to go and start giving them distance B. And distance B, it looks like hell, but it's even easier because distance B, right, is just going to be the integral. So all I'm going to do is show them what I'm going to take. So I'm say, you know what, I'm going to take the distance, and I'm going to say that D equals the definite integral, and it's from 0 to 10, right, of that function, 24t over 2t plus 3, be careful, dt, right? Put it into your calculator and get back 83.336 meters. Okay? Circle that answer. Remember, you don't have to show them all the gyrations of your calculus. Tell them what the calculus question you were solving was. All right? And remember, on this thing for runner A, we just keep going up here, and we have to get our way through this, right? All right, if you have any questions or comments, please let me know. I hope this was helpful in some way to you, and if you haven't already subscribed, please subscribe. Oh, this is AP Exam 2000. This is, I think, yeah, this is Form A, and this was number 2. All right? So I hope it was helpful. Subscribe, please.